quick overview of the lab. Due to the number of questions regarding subnetting and building out this topology, especially since it auto-grades and Packet Tracer is very picky, we're going to do a quick overview. Not a full walkthrough because that'll just give you the answer, but let's get started. In this topology we have 5 LANs, 5 local area networks. We've got a network with 67 hosts. We've got the network with 44 hosts, a network with 21 hosts, a network with 10 hosts, and then there's that point-to-point network between router 1 and router 2 with 2 hosts. 2 hosts because each router uses 1 IP address in order to talk. So we have 5 LANs. Keep that in mind. 67, 44, 21, 10. So in the Word doc, you'll find that you can enter 67, 44, 21, 10. And don't forget about the 2. Now the key thing to start with all of this is we then have to pick the correct block size as well as the subnet IDs. Now the block size is going to be the actual number of total IPs that a subnet mask allows for. 67 fits best in a block size of 128, and 128 would be a /25 subnet mask. Now 44 fits best in a block size of 64, and that would be a /26 subnet mask. If you don't have these memorized yet, make yourself some flashcards and put that to memory. Also, don't forget about that subnet cheat sheet, which is for IPv4, which is inside of our course as well. 21 fits best in a 32, and that would be a /27. 10 fits best in a 16, which would be a /28. And 2 is not a /29. That order doesn't continue. 2 fits best in 4, which is actually a /30. Now this is where we begin, but next we have to pick out the network address. Now remember, you should always start with a step chart from greatest to least. That's why I read it that way in the topology, and that's why I listed it here as well, greatest to least. The easiest way to start with greatest to least then is we start with no unused address space. What does that mean? Always start at the network of .0. But what is the network? Well, if we go back to the Packet Tracer, the network is 192.168.203.0. We'll begin with that. We literally begin with that. So it's 192.168.203.0. Now, that network of .0 consumes 128 total addresses. No, it consumes 67. No, the block size of 128 is the size of the cardboard box we had to select. That size is what we're going to count by. So if we start at .0 and we consume 128 addresses, that's 0 to 127. The next network, if we consume 0 through 127, could only start at 128. And the neat thing about this is we could also check our work if we wanted to. We can start at .0 and just count by 64s. We could have a network of .0, a network of .64, a network of .128, a network of .192, or a network of .256, which is impossible. You can't have 256 as a network. So, .128 is a valid network when you're counting by cardboard box sizes of 64. If we start at 128 and we consume 64 addresses, that would go until 191, which means the next network would be 192. And again, we can verify this. We can count by 32s. Eventually you would find 0, 32, 64, and onwards that 192 is a valid subnet when you're counting by 32s. If we start at 192 and we consume 32 addresses, the next network would begin at 224. 192 up until 223 is 32 addresses. The next network would begin at 224. If we counted by 16s, eventually you'd find 224 is a valid starting point when counting by cardboard box sizes of 16s. Starting at 224 and consuming 16 addresses, the next network would actually start with a 240. So these then are the networks that we would deploy. We take this information, each subnet with its listed network ID and subnet mask, we would now copy and paste and put back into our picture. That first network for the 67 hosts, we would apply it right here with the subnet mask of a /25. That second network for 44 hosts, we'd put that subnet ID here with its mask of a /26. You get it, /27. 10 hosts, /28. Point to point, /30. With those applied here, Now we would take those first usables and broadcast of each one and list them out. So we'd have the first usable be the .1, the broadcast is the last IP in this range, which is 127. 128, first usable is the next address, 129, up until the last one, which is .191. This is literally what we list out across the board. And I'll fill those in for you to do, that should say. But the last one would be 242, and this one would be 241. Now comes the second hardest part of this lab. Follow the instructions. In these bullet points, I tell you exactly what to do. First usable address for R1 for all of its links. Second usable address will be put on the switches on the interface of VLAN 1. First usable address for router 2 for the LAN links, but the WAN should be the second address, which will be 242. And then lastly, the last usable, which is one before the broadcast of each subnet, will be the PCs. That's it for the lab. I hope this helps you out a lot. I hope it really kickstarts you into gear, and enjoy.